Manipulating formulas. So this just, again, it's kind of another way to say what we just did right there. Sometimes though, the variable is in the denominator, which we don't want. And so what do? It says LCD, lowest common denominator. The truth is that it really just needs to be the common denominator, right? So however you get a common denominator, the nice thing about that is you get to remove all denominators, and then you look at an equation with no fractions. And fractions we don't usually like. Fractions have been known to destroy people's lives, so we try to avoid them or get rid of them if we can. Use the distributive property if we need to get rid of some parentheses. We'll combine like terms if it's needed, and then move the specific variable to one side of the equation and all of the terms to the other side. So we need the variable that we're solving for on its own side of the equation, but sometimes you'll have two terms on the same side of the equation. The reason why you need that to happen is so you can factor it out so that it becomes its own term. I think we'll see that. It says use distributive property and multiplication property of equality to get the specified variable alone. Yeah, we'll see. So we're going to solve for r. That's good. Now, like I was saying, what we would like first is to get common denominators everywhere. Now, even though they're using the same variable r, it's r1, r2, and then a non-sub-value here. So I've got a regular r. I'm going to start on the left and I'm going to make each denominator at least have an r. So this first, the r1, it's missing an r, so I need to multiply both the denominator and numerator, right? But then the r2 is missing it as well, so I'm going to multiply r there and then multiply it in the numerator too. Okay, so now I've got at least an r in all of the denominators. That's matching, but they're not still completely matching, which is what we need. Next, I'll do an r1 right there. So r1, it's missing from the first term there, so I'm going to have to multiply the r by r1, but it's numerator as well. And then the r2 is also missing a multiply by r1. But again, if you do it to the denominator, you got to do it to the numerator. So all the terms have a denominator of r and r1, but now we need them to match with r2s as well. So I'm going to have to multiply the first term there. I'll multiply it by r2. And even though the order is different, it doesn't matter because it's multiplication. Yeah, it's great, right? So R2 there and the middle term as well. Okay. So I have got a common denominator all throughout, and since I have that, now I can rewrite the full equation but without any denominators. So I'll put this in kind of its proper order, I suppose. R1, R2, R1 times R2 really, equals R times, I'm going to skip the 1 and just make it times R2 plus the R times 1 times R1. Okay, well that's good, but what the crap are we solving for here? I should have mentioned that. We're solving for R. So I got a couple R's, regular R's, right? I've got this R and I got this R. I don't want two different R's like that, so this is where we got to use, like I was talking about, we got to use some factoring on this. So from those two terms, I'm going to factor out an R, and that would leave me with the parentheses, inside the parentheses, an R2 plus R1. And this still equals R1 times R2. It's not a comma, that's a 1. We're actually pretty close at this point. I'm going to call it a coefficient of R, and it just doesn't look like a regular coefficient, right? Just like our expressions, our answers, they're not looking like regular answers. R2 plus R1. I need to get rid of that, but it's being multiplied by R. The good news is that to solve this, now I got a principle of equality, right? Because I've got an individual R. I can make it all by itself, though, by dividing this side by R2 plus R1, and this side by R2 plus R1. So what do I get? Well, I got R1 times R2 all over R2 plus R1, and I'm sure you probably noticed the order doesn't matter for the addition, but either way. See, and this whole value right there became a phantom 1 for my R. Done. Because we solve for R. It's R by itself. R equals something. And as strange as it sounds, it's exactly the same equation as the one we started with. It's just shown differently, that's all. Yes, sir. I probably should have put those parentheses there. Maybe that would have helped to see that we're dividing the same thing by itself. Just whatever you do on this one, again, a common error because this is very new, right? It's like, what the crap, we can divide both sides by binomial? Yeah, of course we can. That's the nice thing about the principles of equality. But some students tend to just be like, well, I'm going to subtract R1 here, and then I'm going to subtract R2 there, and get something. It looks pretty similar, but it's not the same. And it needs to be the same.